Okay, I'm going to look today at conservation of mass in chemical reactions. The easiest way for us to explain this is to say, let's imagine we had a balance, and on top of that balance, we put two reactants. We're just going to call them A and B. And if we put them both on the balance, and let's say together they had a mass of 56 grams, when we carry out the reaction between them, then the mass of the product at the end is going to be the same, or should be the same. So we've got our combined reactants in here, and obviously the empty beaker here, so that during the course of the chemical reaction, the mass isn't lost. So no mass or no atoms are lost or destroyed in the chemical reaction, they're just rearranged. And that's the law of conservation of mass that we need to know. And that states that no atoms are lost or destroyed in a chemical reaction. Only rearranged. In more simple terms, what we can basically say is that the total mass of the reactants must be equal to the total mass of the products. So whatever happens during our chemical reaction, whatever the mass, the number of atoms that we start with in the reactants, we end up with in the product. So let's have a look at a couple of examples where we're going to put some numbers in. Okay, so the first example we're going to have a look at is the reaction between hydrogen and chlorine to make hydrogen chloride. Now, if we start with 0.2 grams of hydrogen and 7.1 grams of chlorine, when these react, we would expect to produce 7.3 grams of hydrogen chloride, because this and this react together. So the total mass of the reactants here, which adds up to 7.3, is going to be the total mass of the product. So let's have a look at an example question. So we're going to have a look at the reaction between copper sulfate and magnesium, which makes magnesium sulfate and copper. We don't need to worry about the equation too much at the moment, but our example question is going to be 16 grams of copper sulfate produced 12 grams of magnesium sulfate and 6.4 grams of copper. What mass of magnesium must have reacted? So let's write our equation out again underneath, like this. And then we're going to draw a line down here. And we're going to remind ourselves that the formulae that we can see on the left-hand side are the reactants, and the formulae we see on the right-hand side of the product. So the total mass of all of these must equal this. So let's put our information in. We know we've got 16 grams of copper sulfate, we've got 12 grams of magnesium sulfate produced, and 6.4 grams of copper. And we're trying to find out this. So we know enough on this side to say that the total mass of the product is 18.4 grams. And the reason the total mass of the product is 18.4 grams is that and that add together to give us 18.4 grams. If we go back to the other side, then we know that as a result of that, we must also have started with 18.4 grams of the reactants. 16 grams of that is due to copper sulfate. So in order to work out the amount of magnesium, 18.4 grams minus 16 grams gives us 2.4 grams. So the answer to that question is that the mass of magnesium that must have reacted is 2.4 grams. Let's have a look at another example. So in this example, we're going to say that 100 grams of calcium carbonate decomposes to give 56 grams of calcium oxide and an unknown mass of carbon dioxide. Calculate the mass of carbon dioxide produced. So the first thing we're going to need to do is write out a chemical equation. Calcium carbonate decomposes, which means it just, when you heat it, it breaks down to produce calcium oxide and carbon dioxide. Let's do the same thing that we did last time. Draw a line down here and say that this is the reactant. In this case, there's just one, and here are the products. We know that 100 grams of calcium carbonate is the reactant, and there is only one reactant, so that means there's 100 grams there, which means that we must produce 100 grams in total of products. We know also from the question that 56 grams of that is calcium oxide, and the one we're trying to find out is carbon dioxide. So that's going to be equal to 100 grams minus 56 over here. So 100 grams produced minus 56 equals 44 grams of carbon dioxide. Now, there is one exception to our rule. Well, it's not an exception as such, but it's something we need to be aware of. And that's what happens if a reaction produces a gas. Because reactions that produce a gas appear to lose mass. So we're going to have a look at another reaction between calcium carbonate and hydrochloric acid, and that produces calcium chloride, water, and carbon dioxide gas. Now, if we were to look at the same thing we did last time, so we've got reactant A and reactant B, this would be A, this would be B, and we put them on the balance before the reaction, we would find out that these two, just for an example, might weigh 68 grams. Now, once the reaction has been carried out, so we tip the reactants in together, we would find in this case, if we had 68 grams of the total mass of the reactants, that the products only have a mass of 46 grams. And it appears that the reaction has lost mass, that it doesn't obey the law of conservation of mass. Now, that isn't true. The reason being is this reaction produced a gas. In this case, that gas was carbon dioxide, and that gas has escaped into the air, into the atmosphere. So a way that we could prove this would be that, let's say we had our reactants again, 68 grams of them, but this time when we reacted them, we put a bag or balloon over the top of the reaction once we tip them in together, and we'd find that actually this did have a mass of 68 grams because the gas is trapped and held on. Thank you very much.